Hello guys, let's continue our journey in developing the Ant language, and we will continue the concepts of OOP, and this is the last video in OOPs. We will treat super, the keyword super, that refer to the superclass, the class that the subclass inherit from. And you see this example, I have two classes. The first one is the superclass and the second one is the subclass that inherit from the superclass. And also we have some instantiation for the subclass, and then I will call the function the function f. So we have here an override of the function f. So the function that this will be executed is the function that is defined in the subclass. So as you see in the function of the subclass, you see that we call the function of the superclass using the keyword super dot f, and the function will be executed is the function of the superclass. And the next instruction is return super f, that return the closure of the function that exists in the superclass. For the superclass, the function it print the string superclass, and also it print this. This is the reference of the current object. So because we instantiate the object from the subclass, so when we call that this it will be referring to the object of the subclass. So how we will treat the super keyword? So let's take this section of inheritance from the superclass and this function. We will treat it as it is like this. So we will create a scope. We will not create it in the script, but we will create it in the parsing level. We will begin our scope, and we will add to the locals a variable called super, and then the function, we have the function, and then we close the scope. So you should imagine that this code is equivalent to that one. Why I need that? Because I need that the super variable should be like an app variable. So this is a closure, and closure it has app values. So if you didn't watch that video of app values, and I recommend you to go and watch it. So this super is an app value variable. So that's the key idea. And after we end the scope, we need to close that super variable, so the closure can access it without any issues. So I mentioned that in previous video that app values without closing can lead to some issues, because app values is a reference to some value on the stack, but this position on the stack could be changed over time. So the solution is to close that. So you take that value from the stack and put it in some variable, and it can be accessed later. So let's see the stack. So as the stack for the inheritance part, we have the superclass and the subclass, and after inheriting the superclass, the only thing that exists on the top of the stack. So I've mentioned this in previous videos, and I told you that I did it because we will use it in the super section, so it will be handful and useful. So now you will see why. So we have the superclass at the top of the stack. So what we need to do is to create an app value that points to this location. And after the scope is ending, what I need to do is that location should point to a closed variable that hold the superclass. So that's the concept of closing an app value, and go watch the previous videos in sections of functions, and you will see that concept. So we have 3 bytecodes that we need to implement, and the first bytecode is to close an app value. Is a simple bytecode, so at the end of the scope I need to close that app value, because closures, it has a tables of app values. It's a table of app values, so I need to close the app value super so the function can access it later. So the second one, for the instruction super and call the function f, so we need to load to the stack the reference to this, it's the subclass instance. You will see why we need that. And also we get the app value 0 is the super variable, and then we emit a byte to the VM over super invoke, and that will invoke the function f that have number of argument 0 from this superclass. And the last one, we have super.f that return a closure. So what we need is another bytecode that get super. So we will treat that, and you will see, guys, how we will do it. So at the level of the stack, we have the subclass instance, and also we have the class, the superclass. These two things is due to these 2 bytecodes, opl get local and get local 0. We treated in this section. This is the local variable 0 is the variable this, so it's the subclass instance, and it should be at the position, the first position on the stack. And when we get the app value super, we will have the class super. We will use this because we need it to invoke the function from the superclass, and that's normal. For the other thing, why we need that and why we load this to the stack, because we will use it either on the bounding method, because when I will get some function from the class, I need to bound it, because later this function, it could have some calling to this keyword, and it should refer to the sub instance. And also we could use it when we have the keyword this. So in this example, on the superclass, we have print this, and this should point to the subclass instance, because this is inheritance, and also the superclass, it doesn't have any instantiation, so it should have a reference to this. So let's imagine that we did an instantiation of the superclass. When we call the f, it should point to the superclass instance, but when we have, in this case, we have a inheritance, and the subclass should be that one that is referred by this. So that's it, guys, and let's go to the code and see how we will implement that. And let's go. First of all, we'll go to chunk.h, and we will add three bytecode. The first one, up close app value. Second one, up super invoke, and the last one is up get super. So that's it. So let's go and debug that. So case up close app value, it will return a simple instruction up close app value, and with the offset. So second one, up super invoke, we will use the function invoke instruction, and we will pass the opcode string super invoke, and also the chunk also as the offset. and the last one is the up get super, and we will return constant instruction up get super and chunk offset. This up get super, it has also, what is it? Is it? Oh yes, it should have the name of function that we need to get from the super, and that's it. It's not a simple bytecode. So that's it. Okay, so that's it for debugging. So let's clear that and let's go to our compiler and parse that. Vim compiler.c, and I will go after the structure compiler. I need to make another structure, this structure. Class compiler, and this function will help us knowing which function we need to track. The first one, the enclosing the class, and also we need to hold the name of the class, and also we'll hold a boolean value that we check it if this class it has a super class, because I need to raise an error if a class called super init, but it's not a class that inherits from other class, so that's not to be allowed. Also, I will add a function called super, so it will be the handler in the prefix the prefix operation as this. So you see we have taken this, it is treated by this and the function this, and also super, it will be treated by the function super. So that's it for now, and I will initialize the class compiler. Class will name it current class, and it has null. Okay, so let's go after the function this and add the function super, and we will treat that later. We can assign, and we'll treat that. So let's go to the function that handles class declaration. So remember, in the function that parse class declaration, here we will add a scope and end it, and add this local variable super, and so on. So this local variable super, it's not a real token that exists in the code, but it's a synthetic token. It's something not real, and it's just declared under the scene. So let's go, and what we need to do after define variable, I will make class compiler, and class compiler dot enclosing is the current class, and for class compiler name is the parser previous, the name of the function, the name of the class, and class compiler that has super class is false, and current class, it it should be the class compiler. And we check if we have a list. So we have an inheritance. So what we need to do is, as usual, consume the token identifier, get that variable, and also we check if the class is inherit from itself or not. And then what we need to do is to begin the scope. I begin the scope because I need that to be a local variable, and for the perspective of the function or the method, it's an up value. What I need to do is to add local, and the token, I will create it right now. Token, and token start is text, and token length is the, okay, it's not super, the length is the, it's basically it's 5, but I will call the function string length because I need to encapsulate that in a function. And okay, that's it. So let's make that inside the function so we can use it in other steps. So what I need to do is static token, it's a synthetic token, and we'll pass the construct a text on text. And let's copy that here, and it will be more generic. I will pass here text, also here text, and then I will return token, and that's it. So let's call that function here, and the synthetic token in that case is the super keyword, and the add local function, it added that token into the locals array. Synthetic token, I will mark it as initialized so it can affect its scope, and then the usual stuff. Okay, inheritance, and we will need to update the class compiler that has super class will be true. So the other things is also checking the left brace and handling the methods and emitting a pop operation, and the last thing is to check if the class compiler has superclass. We need to end the scope. Okay, and which means that we've treated that and the super exists in the local. Then I will close the scope, and finally I will return the current class to be current class in closing. Okay. So we will go to the function this, and we will refactor this, and we will check the current class if the current class is different. Or is it equal to null, which means that we are not in a class. So this error we have here, we need to close to close the scope. So as I said in the whiteboard, if we close the scope, we need to emit a byte of close up value. So attribute to the structure local, I will add it is captured. Why is that is helpful? So if the local variable is used in the function, so that means is captured. So I need to close. So if we don't have any super inside the function, I will not close on it. That's the idea. I need to know where and when the function, the super variable is used. So if it is used, I will then at the end of the scope I will close that. If doesn't capture it in any function, it will not be closed. It's just a normal thing, and I will just emit a bytecode to pop that variable from the top of the stack. Go to init compiler, and in the function init compiler I will also add this compiler. Okay, let's do it after this. Okay, local is captured, it should be false. That's good, and this will be here. So that's normal things. Okay, that's it. I initialize it for every local should be is captured false, and then so let's go to function up value and see if that keyword super is captured or not. So let's go to that function. In the resolve app value, and if it is local, then we need to treat that local one as captured. It's captured true. Okay, that's it. So directly let's go to end scope, and in the end scope I will check if current compiler locals, and the position is the current compiler local count, locals count -1 is captured. So if it is true, then I will not emit byte of a byte that pop from the stack, but I will emit a byte that tell the VM to close that value, close app value, and else we will emit, and then I will decrement locals count. Okay, that's it. If this local variable is captured, so it is used inside the function, so I need to emit byte of close value. So otherwise it is not used inside the function, so I will just pop it from the stack, and that's it. So now let's go to super, and treat the super function, to treat super keyword. So first thing first, I will check if current class is equal none. So that's mean the super keyword, I need to raise an error. Can't use super outside a subclass. And else if the class doesn't have a super class, so I need to raise an error that says can't use super on a class that has no superclass. Okay, that's it. So I expect after a super keyword token dot, that's the semantic of our language, expects dot after super, and I will consume token identifier, and if not, I will raise an error, expect superclass method name. Okay, and also I will hold some constant for the name that exists after the dot, after super dot, constant, and I will make that constant, and I will pass the parser previous. So I need to load to the stack the variable list, as you see here, which that close in. I need to emit bytes get local 0 because we need to load to the stack the subclass instance. So what I need to do is to call named variable on a synthetic token, and this synthetic token is this. Okay, we need to copy synthetic token here, or I will just make a prototype. So static token, synthetic token, and const char. So that's it. Okay, so I will check if match token left parent, that means we need to treat, that means it is a call, and I will get the argument count by using the function argument list. Also I will emit this byte of get up value by using the same function named variable, but for this case the synthetic token is the super. Synthetic token super, and I will emit first of all 2 bytes. First byte is super invoke, and with that name constant, and then I will emit the last byte is the argument count. So else, which means we have a get, so I need to also name the variable the super, so I can guarantee is that on the stack I have that superclass, and then I will emit bytes up get super with that same name constant. So that's it for super keyword. So that's it. So let's rebuild the project and see if we have any issues, and then we will do it on a simple test, and then we will go to the VM and see how we will interpret these 3 bytecodes. So let's go and let's rebuild and see if we have any issue. We call okay. First issue is captured. So we'll go to compiler.c deadline. So is captured. Okay, the next error is make identifier. Okay, at line 85. Make identifier constant, and also we have match. Okay, also mark initialized. Okay, at the line of mark initialized. So that's it. So let's clear that. So that's good. So let's go and make a sample. So here I'll delete that. Okay, from superclass, and also I will print this, and here I will call super.f, and also I will return a func as superf, and then the output is a function, so I need to call it. So let's see what happened, and we will not see the runtime, debugging for the runtime. I will see just the bytecode if all is okay, and then I will go to the VM to treat these bytecodes. So we have a segment fault. We have super segment fault. So let's go to compiler.c and let's go to super, I think, and here if current class is equal, and also let's go to function add local, and in that for everyone is added, so I will make captured to be false. So that's good. Let's make all, and let's get simple. Okay, it says that we accept. Okay, let's go to sample, and here we'll add so let's redo this. So don't worry about the execution, we'll just worry about the bytecode. So for the f function, you see we have get local 0 and app value 0, and we have the super invoke for f, and also we get the local 0 and get app value, and then we will get super, so and then we return that. So this is the usual ones for invoking and association of that. So the new thing is the close up value. So as you see, when the method is added to the subclass, then we emit byte of close up value to close that value. So that's good. And for the function that exists in the superclass, as you see, we have the printing, get local for this, and then we print that. So that's good. So let's go to our VM. So let's go here and add the first bytecode of close app value, and what I will need to do is to use the close app value that we developed in the section of functions call and app values. So go and watch that video. Close app values, and we'll pass it the top of the stack -1, so we can point to the superclass, and we will pop superclass from the stack and we will break. So let's go and interpret the next bytecode. Is the super invoke, and we will create an object string to hold the method. I will read string. Also I need the argument count. I will read byte, and I need the class superclass as class, and I will pop it from the stack, so it exists at the top of the stack as you see. So I'll pop that to get that value, and then I will call our function that we developed in the previous video, invoke from class. I will pass superclass and then method and count. If it is false, I will return interpret runtime error, and also I will update the frame VM frames VM frame count, and I will break. So let's go for the last one. Is case up get super, and then object string. I will get that name, read string, and also I need the class, object class, super class as class. I will get from the stack, and then I will bound the method. I will pass it the class superclass and name, and then if it is false, I will return interpret runtime error, and I will just break. So in previous videos we treated that bound method that will pass it the superclass and the name, and then it will create an object bound method that hold store the reference to the sub instance, or the reference to this. So we get the class from the stack, so the only object exists on the class now is the subclass instance. So when we bound that, so as you see in the bound method, we create a new bound method on the first object on the stack. So the first object on the stack is sub instance, so this object it remember the this object. So that's it, and let's go to so let's rebuild the project. So everything is good, so let's run it on our sample. So let's see directly the output. So from here, as we analyze our code, so the output should be from superclass, and also should be the subclass instance. And so as you see, we have superclass, it prints superclass, and also it prints subclass instance. And when we return the function f and call it. It also print from superclass, and also it print the sub-instance class. So as you see, from superclass, sub-instance stuff. So go and execute that and see how that is called. So you will see here, let's go to super invoke, I think, yes, here we are, super invoke at 4. So for, as you see, we have super invoke, so the stack we have a sub instance and another sub instance, because we get that value and then run that. So as you see, as you go, and you will understand what is happening. So let's go to debug.h and comment that. So let's clear that. So let's run that from something. So as you see, from subclass for this one, and also it runs the same thing because we return a closures. And remember, these closures, it remember its context. It remember that this is referred to the sub instance. So one thing I need to test is the constructor or the initializer. So init, and I will print superclass initializer. So the subclass doesn't have any initializer, so at the instantiation the initializer should be executed. So let's see. So as you see, the initializer is executed at the instantiation. So let's override it in the subclass. So it should return the subclass initializer. So let's cut that and let's execute it. So as you see, subclass initializer. So let's test one more thing, and I will use the super here, and the superclass doesn't have any inheritance, so I will do just print super, and as you will see, it should print an error. So superclass can't be used on a class that has no superclass. So for this name, it doesn't have any superclass. So let's test another thing. So let's use super here. So 2 errors. The second errors, can't use super outside a subclass. So also let's test an error, another error. So let's see that, let's suppose that someone did this super.f and it put 10 on it. So this new script, it changed the superclass function and it put 10 instead. So what will happen? So as you see, error, invalid assignment target. So that is not allowed in our semantic model language. So guys, see you in another session. Now we've accomplished something really good. We've developed the entire concepts of the OOP. So see you guys in other session, just to optimize our language with some methods, and also after that we will develop the garbage collector. So see you guys in another session. So go and run the code and understand what happens in the internals of Ant language, and have fun, guys.